Okay, I think we're recording. Let's take a look at some of these uniform motion problems. Here you have May, and she's leaving out her back door, going to the rear of her garden, and then she's returning back to her back door. Now, on the way out to her garden, she walks at an average speed of 8 feet per minute, and along the way, and on her way back, she walked an average speed of 16 feet per minute. If the round trip took 21 minutes, how far in feet is it from her back door to the rear of her garden? So she's gathering blackberries. So that's why when she's going out that she's walking slower, that she must be picking the blackberries. And then when she's done and turns around and goes back to her back door to go in the house, she just walks straight in. So that's why she's walking faster, or at least that's what I would assume. So the distance on the way out to her garden, to the edge of the garden, is the same distance when she walks back inside her house to the back door. So we know that distance is equal to rate times time. So we want to look and see if there's information about the rate and the time as she walks out of the house towards the rear of the garden, picking blackberries along the way. And we look to see if there's information about her rate and her time as she returns to the back door, as she returns to the house to go inside the house. Alright, so when she's picking berries, she's walking at 8 feet per minute. She's walking back to the house 16 feet per minute. Now, I don't know the time that she walked out to the garden, nor do I know the time that it took for her to return, but I do know the total time. So if I let X be the time that she walks out to the edge of her garden picking the berries, then I know that the return trip is 21 minus X, because I know the total time has to be 21 minutes. So if you called the X the time out and Y the time to come back in, if that total time is 21, all I'm doing is writing an expression for the time that it takes for her to come back in, which is 21 minus X. So if we multiply this, we've got 8X is equal to 16 times 21 is probably 336. Yeah. To solve this for X, let's add 16X to both sides. Let's divide by 24, which is probably 14. So remember that my variable was the length of time that it took for her to walk out to the edge of her garden. So that's in minutes. And that's the length of time that it took for her to walk out to the edge of her garden. Now that's not what the problem is asking for. The problem is asking for how far in feet is it from her back door to the rear of the garden. So I can take this X and plug it in to either side of the equation, because the distance to walk out to the edge of the garden is the same as the distance from walking from the edge back to the house. So all I have to do is multiply this by 8. And that's 112, I believe. So 112 feet. Let's double check that. Okay. guess technically it says rear of her garden. All right, does that make sense? That she walks out at a rate of 8 feet per minute, picking blackberries along the way. She walks out, that the length of time it takes her to walk out is 14 minutes. She's finished. She turns around and she's walking faster. 21 minus 14 is 7. It only takes her 7 minutes to walk back into the house. The 8 times 14, she walked 112 feet out to the rear of her garden, then turned around and walked 112 feet back to her house. Had we plugged in the 14 on the right hand side, we would have had 16 times, 21 minus 14 is 7. You can see that's also 112. All right. Now there's another way that we could do this problem, so let's illustrate it. And we should get the same answer, just doing it in a different way. From the wording of the problem, with the total time being 21 minutes, we know that if the total time is broken down into the time that it takes her to walk out to the rear of the garden plus the time that it takes for her to walk back to the house, back inside the house, so she's going out and then she's turning around and coming back in. If that total time is 21 minutes, on the right hand side we've got time. Time is equal to distance divided by rate. And that's as she's going out, picking the berries, walking away from the home. And here, distance divided by rate, as she's finished picking the berries and she's returning to go back inside the house. So the distance is the same. Let's let that distance be x. We know that the rate that she walked out was, she's walking slower, the 8 feet per minute, and walking back in 16 feet per minute. So we have this rational equation to solve. If we get a common denominator of 16, we'll have to multiply this by 16 divided by 16, this by 2 divided by 2, and that has the denominator we need, 16. So 16 times 21 is probably 336, but let's double check. Yeah. Two x, 16, x, 16. So if we clear the denominator, if we multiply every term by 16, both sides of the equation by 16, we get 336 is equal to 2x plus 1x. That's 3x. If we divide by 3, we get x, and x represented the distance to the rear of the garden, and that's what it asked for, is as how far is it from her back door to the rear of her garden. 112 feet. 336 divided by 3. So those two different ways to get the same problem. Hope that helps. Let's move on to the next one. So again, we have a round trip situation. Carlos is traveling to his friend's house, then he's turning around and going back home. Just like May went out to the rear of her garden, turned around and came back home. Alright, so the distance that Carlos drove to see his friend is the same distance that Carlos drove to return home. We know that distance is equal to rate times time. We want to find information about the rate and the time as he goes out to visit the friend, and the rate times the time when he's out there and returning home. Alright, so let's see if we can substitute anything in for known values or define our variables. The average trip there, the average rate on the trip there was 40 kilometers per hour. And on the way back, 30 kilometers per hour. It took 1 hour less time to get there than it did to get back. Well, here he's driving faster, so this is going to be the lesser time. Here you're driving slower, it's going to take you more time to travel that same distance. So if we let x be the time that it takes to return home, then the length of time that it took to get there was faster 1 hour. Okay, so we set this equal to each other and solve for x. I have defined here x to be the time that it takes to return home. I could have had the x over here, then that would be x plus 1. So I have 40x minus 40 is equal to 30x. If we add 40 to both sides and subtract 30x from both sides, divide by 10, and I have that x is equal to 4. So it took 4 hours for him to return home, and 4 minus 1 is 3. It took 3 hours for him to get to his friend's house. So, excuse me, it's taking, no, I'm going to have to edit this. It's taking 4 hours to return home.